I want you to picture something for a second. Picture an Alaskan fishing family waking up way before dawn.
Right, in that absolutely biting mid-latitude string air.
Exactly. It's freezing. They're pouring out this terrible, scalding thermos coffee, uh, checking the hydraulics on their winches, and just prepping their boat for the commercial salmon season.
A season that their entire livelihood depends on, by the way.
Yeah, 100%. Their whole economic their ability to pay the mortgage, to put their kids through school, to keep the business going for another generation, it all hinges on one single numerical quota.
And that quota dictates exactly how many days they get on the water and, how many nets they can legally cast.
Right. Now, you might think that number is just some rough estimate, but it's not.
No, definitely not. It's the end product of this incredibly complex, highly localized ecosystem model.
Run on literal supercomputers by federal scientists.
Yeah, it really is the razor's edge of modern population dynamics.
But here is the profound twist, and this is exactly what we are unpacking today.
The weird historical connection.
Yes. That modern supercomputer model, and therefore the actual present-day reality of this Alaskan family, is fundamentally tethered to the obsessive note-taking habits of a 19th century Victorian bird collector.
A guy who lived over a century and a half ago. It's just wild.
It really is. So welcome to the deep dive. Today, our mission is to trace that exact unbroken line.
We're going way back.
We are going to explore the absolute origins of American fisheries science, starting with this really localized, highly volatile dispute over a vanishing fish off the coast of New England in the 1870s.
And we'll watch how that specific dispute birthed this massive scientific legacy that currently manages our oceans today.
But we are also going to look at the fragility of that system. Because, well, the stakes of this history are incredibly immediate for you, for everyone listening.
Right. We are examining the very foundation of how a government understands the natural resources it's supposed to protect.
And what happens when that century-and-a-half-old legacy faces a real existential threat?
Exactly. To build this timeline, we've got an extensive stack of sources in front of us today.
A huge stack. We're pulling directly from public domain, U.S. government documents, historical archives from the Smithsonian Institution, and the National Oceanic and Atmospheric Administration's own historical timelines.
Or NOAA, as most people know them. And critically, we're also using contemporary investigative reporting from Civil Eats and Manga Bay News.
The goal here is to really let the numbers breathe, to understand the mechanics of a science that honestly operates almost entirely out of public view.
Which requires a certain duality in how we approach this material because, the 19th century naturalists who built this system, they were brilliant.
They were total quirky polymaths.
Right, and it's so easy to view them through this lens of, historical affection. But the mechanisms they built are deadly serious.
Yeah, the statistical baselines, the frameworks for measuring the invisible.
Exactly. Those baselines are literally the only thing standing between sustainable extraction and total ecological collapse.
So let's drop right into the catalyst of this entire timeline. Take us back to the 1870s.
Okay, so it's the 1870s on the coastal waters of New England, Massachusetts, Rhode Island, Connecticut.
The post-Civil War industrial boom is just in full swing.
It is. And the coastal fishing communities start noticing this terrifying biological anomaly.
The fish are vanishing.
Right. The critical coastal food and forage fish, we're talking species like menhaden, shad, alewives, they're experiencing a severe, undeniable population crash.
And we need to understand the economic structure of these communities, to grasp why this crash was such a huge deal.
Yeah, because these weren't just recreational species for weekend fishing trips.
Not at all. Menhaden, for instance, they were the absolute cornerstone of this massive, burgeoning fertilizer and oil industry.
And shad and alewives sustained entire regional food networks.
So when those catches began to plummet, it wasn't just a minor inconvenience, right?
No, it was a systemic economic shock. People were panicking.
And when a localized economy goes into shock, the immediate political reflex is to find a scapegoat.
Always. Which gives us the foundational political conflict of American fisheries.
Right. We have two very distinct factions of fishermen pointing fingers squarely at each other.
On one side, we have the trap fishermen.
Let's actually look at the mechanics of what they were doing, because my understanding from the source documents is that this wasn't just a difference in the size of their boat.
Oh, no. It was a fundamental shift in extraction technology. It was literally the industrialization of the shoreline.
How so? What did it look like?
Well, the trap fishermen were using these massive stationary gears known as bulk weirs, and pounds.
Okay, weirs and pounds.
Right. So to visualize this, I want you to imagine a long, heavy fence of netting. They called it a leader.
Just sticking right out into the ocean.
Exactly. Stretching perpendicularly from the shore all the way out into the deeper water.
Okay, I can picture that.
So when these huge schools of coastal fish migrate, and they usually swim parallel to the shoreline, they eventually just run smack into this leader.
And their natural instinct, I assume, is to turn and swim toward deeper water to get around the obstacle.
Yes, but the leader directs them into this series of complex, heart-shaped net enclosures.
Oh, wow. So it's like a trap.
A massive one. They're funneled through increasingly narrow openings until they end up in the final pound.
Which is what, exactly?
It's this huge netting bowl where they are just trapped alive.
Man. So the trap fishermen just row out there and take them?
Basically, they simply pull their boats up to the pound and scoop out thousands of pounds of fish in a single haul.
And this thing is just sitting there in the water all day.
Operating 24 hours a day, entirely passively, intercepting these massive migrations.
Which naturally completely enraged the other faction, the handliner.
Right. The traditional small boat operators.
Yeah.
The shore anglers working with just single lines or small active nets.
They're looking at these sprawling industrial weirs, just intercepting entire schools of fish before they can even reach the traditional fishing grounds.
And they conclude pretty logically, from their perspective, that the trap fishermen are annihilating the fishery.
So they go to Washington. They lobby Congress, demanding a total ban on fixed traps.
But the trap fishermen, they counter-lobbied with equal ferocity.
Of course they did. They had a lot of money on the line.
They argued that their gear was simply more efficient, and that the decline in catches had absolutely nothing to do with human extraction.
Wait, they blamed it on nature.
Completely. They blamed shifting ocean temperatures, changing currents, natural predators.
Anything but their nets.
Right. They argued that the fish simply moved offshore, beyond the reach of the handliners.
Okay, let's unpack this. Because if I'm looking at this from the perspective of an 1870s congressional committee, the obvious solution seems to be an audit.
An audit of the ocean.
Well, think about it like this. It's like two people arguing over who is draining a joint bank account, but neither of them has ever actually looked at a bank statement.
Right, they just know the money is gone.
Exactly. So if you're the government, you subpoena the bank statements. Why couldn't they just subpoena the catch ledgers from both the trap fishermen and the handliners, run the math, and figure out who is right?
What's fascinating here is that approach fundamentally misinterprets the opaque nature of the ocean.
How do you mean?
Well, the catch ledgers, the bank statements in your analogy, they were structurally confounded.
Because they're just numbers on a page.
Exactly. If a handliner's ledger shows a 50% drop in catch over 3 years, you cannot mathematically prove why that happened.
Right. It doesn't tell you the cause.
You don't know if the total population of fish in the ocean actually dropped by 50%, or if the fish just shifted their migration route 5 miles further offshore because of a thermal anomaly.
Oh, I see. So a high catch rate doesn't necessarily mean high abundance in the ocean?
Not at all. It might just mean the trap fishermen built a longer weir. Or maybe they just intercepted a highly concentrated school, which would mask an overall population decline.
That is just a nightmare for management.
It's the core epistemological nightmare of marine management. The ocean is this three-dimensional, opaque, fluid environment.
You can't just stand in a field and count the herd.
Exactly. You are trying to govern a resource that moves invisibly, aggregates unpredictably, and operates on spawning schedules entirely hidden from terrestrial observation.
So relying on what they caught, relying on fishery-dependent data is basically useless for knowing what's actually down there.
It only tells you how effective the humans were at extracting. It tells you almost nothing reliable about the actual objective state of the biological population.
Okay, so faced with this complete informational void and with the New England fishing economy literally threatening to tear itself apart, Congress actually takes a highly unusual step.
They did. On February 9, 1871, they passed a joint resolution establishing the United States Commission of Fish and Fisheries.
Which is a huge deal.
It really is. The mandate of this commission is so worth analyzing because it represents a profound philosophical shift for the government.
Because it wasn't just an economic development board, right? Like it wasn't designed to subsidize boat building or open new markets.
No, its explicit statutory mandate was to investigate the biological causes for the decrease in commercial fish.
To separate the natural fluctuations from the human impacts.
Exactly, and to recommend remedies.
But there is a massive catch here. The critical limitation of this new commission is that it possessed absolutely zero regulatory power.
None whatsoever.
It couldn't find the trap fishermen, it couldn't tear down the weirs, it couldn't establish
It
quotas,
was a purely investigatory scientific body.
which meant its entire authority, any power it was going to have, would have to be derived from the unimpeachable quality of its data.
Right. They had to be so scientifically rigorous that no one could argue with them.
And to achieve that, President Ulysses S. Grant needed to appoint someone with a staggering capacity for data synthesis.
And he didn't appoint a politician or some commercial fishing baron.
No, he appointed Spencer Baird.
And Baird is the fascinating anomaly at the center of this entire history.
He really is. He was born in Pennsylvania in 1823, and his background was not in marine navigation. It wasn't in commercial fishing.
He was an ornithologist,
A bird collector.
but a prodigious one. The historical records show that by age 14, his meticulous nature had earned him the attention of John James Audubon.
Wait, the Audubon?
The Audubon. Audubon was so struck by Baird's systematic approach to classification that he actually gifted the teenager a portion of his own personal bird collection.
That is wild, and that systematic approach basically defined his entire career.
It really did. By 1850, Baird had become the assistant secretary of the Smithsonian Institution in Washington, D.C.
And the transformation he engineered at the Smithsonian, I think this is critical to understanding how he later approached the ocean.
Oh, absolutely. When he arrived, the Smithsonian's natural history collection consisted of roughly 6,000 specimens.
Okay.
By the time of his death in 1887, he had grown that archive to over 2 million specimens.
2 million from 6,000.
Yes. The logistics of that expansion in the mid-19th century are just astounding.
I mean, how did he even do that?
He built an empire of biological accumulation. He leveraged the westward expansion of the United States using the transcontinental railway surveys, military outposts, frontier expeditions.
He was basically crowdsourcing science before that was even a concept.
Exactly. He established a network of hundreds of correspondents, army surgeons, surveyors, amateur naturalists, and he instructed them on exactly how to prepare, label, and ship biological specimens back to Washington.
So he mapped the terrestrial biology of North America. But I have to challenge this a little bit.
Sure, go ahead.
If I look at the leap he makes in 1871, the underlying logic is kind of confusing.
How so?
Well, birds sit in trees, they fly in the sky where you can see them, you can physically secure a specimen and study it in a lab.
Right.
Fish are literally hidden in the dark, underwater. How does the mindset of a museum archivist who is used to static observable things translate to the ocean?
It translates precisely because Baird recognized that the ocean couldn't be understood through simple observation. It had to be understood through accumulation.
Okay, explain that.
He realized that the framework of the museum archive, the rigorous, systematic gathering of localized data points over long periods of time, was the only way to penetrate the opacity of the water.
So you can't just understand a species from one fish or one season.
Exactly. He didn't view the New England fish crash as just some localized political dispute. He viewed it as a massive gap in the natural archive.
So his goal wasn't actually to go to New England and mediate between the fishermen.
No, his goal was to initiate the archival cataloging of the entire marine environment.
Wow. Okay, so armed with this philosophy, Baird heads up to Cape Cod.
Right, to this tiny, sleepy village called Woods Hole, Massachusetts, in the early summer of 1871.
Which was spelled with an H-O-L-L at the time, right?
Yes, fun historical fact. And when he arrives, he isn't acting as an arbiter. He's an investigator.
He borrows space from the local lighthouse board, sets up a really rudimentary collecting station on Little Harbor, and just gets to work.
Initiating the very first systematic study of a declining American marine fishery.
But the political pressure he was under must have been intense.
Oh, incredibly volatile. Imagine it. He's sitting at this borrowed desk, surrounded by angry handliners demanding he abolish the weirs immediately.
And the trap fishermen breathing down his neck demanding federal protection.
And Congress just wants a rapid assessment. They want him to pick a side, provide some political cover, and go home.
But this is where Baird's scientific rigor completely overrides the political pressure.
It's his defining moment. He absolutely refused to be rushed. He refused to provide just some theoretical answer based on a few weeks of observation.
Because he knew that would be scientifically hollow.
And easily dismissed by whichever side lost the ruling. So what does he do? He stays.
He spent 2 full, grueling field seasons in 1871 and 1872 gathering empirical data.
And The methodology of that data gathering is what sets the foundation for everything that follows in marine science.
Right, because he didn't just walk down to the docks and ask the fishermen what they caught.
No, he basically invented the concept of the ecosystem survey.
He was out there taking highly detailed water temperature readings at varying depths to track thermal boundaries.
He was cataloging the stomach contents of predators to build early food web models. He analyzed the specific mesh sizes of the weirs.
He was isolating the variables.
Exactly. And the result of those 2 years of isolation is his massive 1872 report to Congress.
The report on the condition of the sea fisheries of the south coast of New England.
Right. And what's brilliant about this document is its refusal to offer a simplified narrative.
He didn't just say, humans did it.
No, he didn't exonerate the trap fishermen, but he didn't entirely validate the handliners either. It's a masterclass in early ecosystem modeling.
So what did he actually conclude?
He concluded that the collapse of the fish was the result of a multivariable trophic cascade.
Meaning multiple things went wrong at once.
Yes. First, he validated the trap fishermen's claims about natural forces. He extensively documented that massive schools of bluefish, which are highly aggressive natural predators, had altered their migration patterns,
And they were just tearing through the forage fish.
inflicting catastrophic mortality rates on the menhaden and alewives.
So natural predation was a massive driver of the decline.
It was. But then Baird pivoted, and he applied his empirical data to the human side of the equation.
This is where the trap fishermen get caught.
Right. He demonstrated that while the bluefish were decimating the populations offshore, the industrial weirs were intercepting the surviving breeding stock before they could enter the estuaries to spawn.
So it's a compounding event.
The natural predators strip the population, and the human technology prevents the population from replenishing itself.
There is a specific quote in the archival sources from Baird's interviews with the trap operators that I just found fascinating.
Oh, the one about extraction.
Yeah. It perfectly encapsulates the industrial mindset of the time. The fishermen literally told him their goal was to extract, quoting directly here, the largest supply in the shortest possible time.
Which is just the defining ethos of unregulated, open-access resource extraction.
Get as much as you can, as fast as you can.
Because it operates on this assumption of infinite biological elasticity. The idea that no matter how hard you hit the ocean, it will always just instantly rebound.
And Baird uses his data to just systematically dismantle that assumption.
He really does. He introduces what is essentially the proto-concept of maximum sustainable yield.
He proves to Congress that extracting the largest supply in the shortest time mathematically guarantees the exhaustion of the resource.
Right. If the mortality rate, meaning the bluefish plus the human extraction, exceeds the rate of new fish being born, the fishery hits zero. It's just math.
But proving the decline was really just step one for him, wasn't it?
It was. The true genius of Baird wasn't just diagnosing the collapse in 1872. It was recognizing that a single diagnosis is totally insufficient for long-term management.
Right, because the ocean changes every year.
Exactly. He realized that to manage that dynamic volatility, the Commission couldn't just drop a report on Congress's desk and disband.
They needed to continuously monitor the ecosystem.
To detect the next collapse before it actually happened.
Which brings us to this conceptual anchor of modern fisheries management, the distinction between fishery-dependent and fishery-independent data.
This is such a crucial concept for listeners to grasp. This is the epistemological breakthrough.
Okay, so let's break this down. Here's where it gets really interesting. Fishery-dependent data, like we mentioned earlier with the catch ledgers, is inherently biased.
Very biased. It's influenced by market prices, fuel costs, gear upgrades.
The skill of the captain.
Exactly. If the price of fish drops, fishermen might just stay home. And then the catch data shows a massive decline, even if the ocean is full of fish.
To put this in a way that's easy to visualize relying on fishery-dependent data is like asking a hunter how many deer are in the woods based entirely on what they shot that day. But maybe it was raining, so the hunter stayed in their truck. Or maybe they went to a different county.
Their hunting log tells you almost nothing about the actual health of the forest.
Exactly. So to understand the forest, you need fishery-independent data.
Which is like sending out a team of scientists with cameras to map the entire woods, regardless of the weather or the market price of venison.
But how did Baird actually implement that in the 1870s ocean? Like, you're operating with 19th century canvas and hemp ropes. How do you standardize a marine survey?
By meticulously standardizing the variables of extraction. His teams didn't fish for profit. They fished for data.
So they controlled exactly how they fished.
Exactly. They used standardized trawl nets with highly specific mesh sizes. They towed those nets at exact speeds for exact durations at precisely recorded depths.
They created a standardized unit of effort.
Yes. So if a standardized net towed for exactly 30 minutes caught 100 pounds of fish in 1875, and then that exact same net towed in the exact same location for 30 minutes caught 10 pounds of fish in 1880.
You've isolated the variable.
You have empirical proof of a population decline, completely independent of human economics.
And when you string those standardized data points together, year after year, decade after decade, you generate what marine scientists refer to as the time series.
The time series. It is the holy grail of ecological management.
The unbroken record of biological fluctuation. Let's really deeply unpack the statistical power of this because it's so important.
Okay, let's do it.
If I go out to Massachusetts Bay today and I execute a perfectly standardized trawl and I pull up 5,000 pounds of cod, that number just by itself is practically meaningless, isn't it?
Completely meaningless. It is a single data point floating in a historical void.
Right. Is 5,000 pounds the remnant of a once massive stock on the verge of extinction? Or is it a historic high because of a great spawning season?
You have no idea.
Wrong.
Without context, a single point of data provides zero predictive power.
But if I have 10 years of those identical trawls, I start to see a trend line.
The numbers start to breathe.
Right. And if I have 50 years or a century of that data,
then you possess the statistical architecture of the entire ecosystem.
you can filter out the noise.
Exactly. A century-long time series allows population dynamicists to identify multi-decadal cycles, like the Pacific Decadal Oscillation, which naturally drives fish populations up and down.
It establishes the absolute baseline of natural variation.
And only by understanding that complete historical baseline can a scientist pinpoint the exact moment when human overfishing begins to artificially depress the stock.
To build a time series that robust, Baird knew he couldn't just keep renting sailboats.
No, he needed dedicated infrastructure. He needed to push off the coastal shelf and into the deep ocean.
So he leverages his political capital, goes back to Congress in 1881, and secures an appropriation of $148,000.
Which was a staggering sum of money at the time.
To construct a fully customized, ocean-going research vessel, the USS Albatross.
Launched in 1882. And historical records indicate this was the very first vessel built by any government in the world explicitly and exclusively for marine research.
It physically manifested his time series.
It really did. It was designed for deep water extraction.
Yeah.
It had these massive steam-powered winches that could drop dredges thousands of fathoms down.
It even had specialized deep-sea thermometers to map the Gulf Stream.
And extensive, naturally lit laboratories right on the main deck. Scientists could dissect and preserve specimens the moment they came out of the water.
So he's building this massive scientific apparatus.
Avant.
But I keep wondering, how was he paying for all this without stepping on political landmines?
Ah, the bureaucratic shielding.
Because he's effectively telling a highly lucrative industrial sector that they are exhausting their own product. And he's asking Congress for hundreds of thousands of dollars for pure science.
Right. So how does he survive? He survives because he held two jobs at the same time.
Right. He was still the Assistant Secretary of the Smithsonian.
And in 1878, he's actually elevated to the position of secretary, which is the highest scientific office in the United States.
The absolute apex of American institutional science.
But he did not resign his position as the U.S. Fish Commissioner. He held both roles simultaneously for 16 years.
And he took no pay for the Fish Commissioner role, right?
Not a single cent. He subsisted entirely on his Smithsonian compensation.
If we connect this to the bigger picture, that arrangement is just genius.
It made him completely immune to standard political leverage.
Right, because if a senator from a fishing state is unhappy with the commission's findings, they can't threaten to cut his salary. He doesn't have one.
Exactly. And more importantly, because he was the head of the Smithsonian, the Fish Commission was suddenly imbued with the prestige of the nation's premier scientific institution.
Congress was highly reluctant to question the empirical methodology of the man who literally ran the Smithsonian.
The Smithsonian's credibility shielded the Fish Commission. It allowed him to cement his physical legacy in Woods Hole, turning it into a world-class scientific hub.
Which eventually leads to the Marine Biological Laboratory, the MBL.
Right. But there is a nuanced, contested point in the sources here that we have to bring up.
The hatcheries.
The hatcheries. Because Baird couldn't just offer politicians the promise of a multi-decadal data set. He had to offer them immediate, tangible results to keep the funding flowing.
So he sets up federal fish hatcheries, like the Baird Station on the McCloud River in California in 1875, which was designed to artificially propagate Pacific salmon.
The theory being, if human extraction is outpacing natural recruitment, you just bypass nature. You artificially fertilize millions of eggs, rear them in tanks, and flood the rivers with hatchery fry.
Sounds like an elegant mechanical solution to an 1870s Congress? But wait, looking back with modern science, didn't those hatcheries actually cause massive
Oh,
problems?
catastrophic problems. Modern genetics have revealed the massive flaws in that logic.
Because if Baird's entire philosophy is observing the natural baseline, doesn't artificially dumping millions of identical fish into a river completely contaminate his own data set?
Yes, it profoundly confounded the data. But the biological damage was even worse.
How so?
Wild salmon populations are hyper-adapted to their specific natal streams. They have localized genetic traits for migration timing, disease resistance.
Evolved over millennia.
Right. Hatchery fish, on the other hand, are selected for their ability to survive in concrete tanks and eat pelletized food.
So when you release them into the wild,
They compete aggressively with the wild juveniles, and when they return to spawn, they interbreed with the wild stock.
diluting the genetics.
It causes genetic dilution, outbreeding depression. It severely reduces the overall fitness of the entire population.
It's a genuine tension in his legacy, doing harm while trying to do good.
He essentially mortgaged a portion of the biological reality to fund the long-term observation of it.
Wow. So Baird passed away in 1887. He spent 16 years building this apparatus, but the true miracle here isn't just that he started the time series.
It's that the time series survived.
It had to survive a century of bureaucratic chaos, and bureaucracy's fundamentally hostile to long-term continuity.
Agencies are routinely dismantled, budgets are slashed. Maintaining an unbroken survey through a century of reorganizations is a staggering achievement.
Let's outline those shifts quickly because it's dizzying. In 1903, the Independent Commission is dissolved and absorbed into the Department of Commerce and Labor.
Framing fish as commercial commodities.
Then in 1940, it's moved to the U.S. Fish and Wildlife Service under the Department of the Interior.
Shifting the focus back toward ecological preservation.
By 1956, it's the Bureau of Commercial Fisheries. And then finally, in 1970, it's reborn as the National Marine Fisheries Service, or NMFS.
Under NOAA, back in the Department of Commerce.
So what does this all mean? It's like a priceless family heirloom being passed around between different distant relatives for 100 years. You subject any program to that many administrative overhauls, it usually shatters.
But the miracle is, the data series survived every single one.
The administrative letterheads changed, but the scientists in the field kept standardizing the trawls.
They kept meticulously adding dots to the historical trend line. The commitment to fishery-independent data remained unbroken.
And that unbroken chain leads us directly from the 1870s to the icy waters of the Pacific Northwest today.
Back to our Alaskan family preparing their boat for the salmon season.
Right, because the modern Alaska salmon stock assessment, it's a marvel. They use split-beam acoustic sonar systems now.
Which can actually calculate the size and density of individual fish within a massive school.
They deploy environmental DNA sampling to detect genetic traces in the water. They use supercomputers.
The tech is brand new, but the underlying question is exactly the same one Baird asked in 1871.
How many fish are there, and is our harvest rate sustainable?
Exactly. And the value of the baseline is everything here. Let's say the sonar survey shows a 30% drop in salmon biomass this year.
In a vacuum, a 30% drop looks like a total collapse. You'd have to shut down the fishery immediately to prevent extinction.
Ground the fleet. Bankrupt the family. But because NOAA scientists have a time series stretching back decades, they don't operate in a vacuum. They cross-reference that drop against the historical baseline.
And they realize, oh, this specific stock naturally drops 30% every 12 years because of ocean currents.
It's a temporary blip, so they can safely authorize a sustainable commercial quota. The Alaskan family gets to fish, they pay their mortgage, and the ecosystem is secure.
We only know it's a blip because we have a century and a half of data to compare it to.
The entire economic viability of the modern fleet is subsidized by the accumulated science of the past.
But what happens when the people responsible for keeping that baseline alive are suddenly removed?
This is where it gets highly concerning.
Now, before we get into this next part, I want to make it absolutely clear to you, the listener, that we are not taking sides here. We are not endorsing any political viewpoints.
Right, we are simply reporting the events and ideas exactly as they are laid out in our source material.
Strictly analyzing the mechanical impact on the time series based on the reporting from Civil Eats and Manga Bay.
So what did the sources say about 2025 and 2026?
According to the documents, in 2025, the incoming administration fired over 800 NOAA employees.
And nearly 550 of those were specifically from NOAA Fisheries.
In an agency of roughly 3,000, that is a massive loss of specialized capacity. And then, a proposed 2026 budget sought to cut fisheries science funding by 42%.
A 42% cut to the core scientific infrastructure.
What is the real-world impact of that?
Well, the contemporary reporting cites John Hare, a science director at NOAA. He detailed how 5 scheduled stock assessments simply couldn't be completed.
They lacked the personnel to process the data.
Exactly. But it also paralyzed the regulatory machinery. The New England scallop fishery had to shut down mid-season.
Not because there weren't any scallops.
No, the ocean was full of them. The fleet was grounded because NOAA didn't have the analysts left to approve the annual rule on time. Without the finalized legal rule, fishing is a federal crime.
We are seeing the 1870s play out again. Fishermen are grounded not because there aren't any fish, but because there is no one left to count them.
It's a tragic irony. And the terrifying part is, once a time series is broken, you can't just fix it later.
Right. You can't go back in time to 2026 and measure the ocean.
A gap in the data is a permanent blind spot. And when models hit a blind spot, statistical uncertainty skyrockets.
And under the law, high uncertainty means regulators have to lower quotas.
Breaking the time series today mathematically guarantees that Alaskan family will face lower quotas a decade from now.
Because the supercomputers won't have the certainty to authorize a full harvest.
When you stop measuring, you stop knowing.
It is an incredible journey we've tracked today. Spencer Baird, a man who collected birds, built an institution that counted the invisible fish of the sea.
Creating a 150-year unbroken chain of knowledge that keeps our oceans alive and our coastal families fed.
It shows that rigorous measurement is really the most fundamental form of governance.
It takes centuries of quiet commitment to build that baseline of truth, and only a single budget cycle to destroy it.
Which leaves me with a final lingering question for you to mull over today. If the unbroken record of the natural world snaps,
If we willingly introduce permanent blind spots,
and our baselines shift in the dark, without us out there to measure them, how will our grandchildren ever know what they've lost?
they won't. They'll just assume the empty ocean they inherit is how it's always been.
Thank you so much for joining us on this deep dive. Keep looking closely at the baselines, and we'll see you next time.